Michaelis menten equation is an enzymatic reaction which is an equilibrium reaction. Say we have enzyme E, let's represent the enzyme as E, reacting with substrate following forward reaction K1 to form ES. This is an intermediate. Then this again going backward reaction K minus 1. This is subscript, please. K1. Then this is, if this goes follow second order reaction to form product. This is an equilibrium reaction, so you try to eliminate this because it's an intermediate, and this is the rate determining step. The velocity of the reaction is this rate determining step for the product to be formed. So how do we eliminate this and we get our Michaelis menten equation? We write the rate of reaction in terms of this. So for the forward reaction, this plus this going forward reaction to form EX, you have the E, concentration of ES, over the T to be equals to, this is the product. So we are writing down of the product, which will be plus K1E and S, the concentration of this is the reactant. You see we have I, the E, S again, the T, concentration of ES equals to ES going back, following backward reaction to form this. This is the reactant, so we are writing in terms of reactant. Reactant decreases with time, so we have K minus 1 minus K minus 1 ES following backward reaction. This is the reactant forming this and this. So this I2, then say we are writing the concentration of ES all over the T going, this is second order reaction to form product. The rate at which this break down to form product, and again this is the reactant, so it will be minus K2 EX equation 3. Then putting the three equations together, we have, and using steady state approximation, we have our K1E S, this minus K minus 1 EX minus K2 ES to be equals to 0, but before the reaction commences, say we have, let me use limestone as an example. The composition of a limestone, so you have CaCO3 in nuclear reaction to form calcium oxide plus carbon dioxide. Before the reaction commences, as time t equals to 0, we have 100% of calcium hydroxide. But as the reaction proceeds, let's say at 5 minutes, we have 40% of this and 60% of this. So at that particular time, for us to get the concentration of this, we have to add this together to get the initial concentration of this. When the reaction has proceeded, as breaking down to 2 for the forward reaction. The same thing applies here. So what do? Let me say my enzyme E0 is E0 equals to E plus ES. So let's say this is our E0. So at the particular time, for me to know this, to get this E, I have to subtract this from this. For this same thing, this represent this, this represent this, this represent this. So for me to know, I have to substitute. Then to get E now, our E equals to E0 minus ES. Take this to the other side. Let's see, this is our equation 1. Now let me say this is equation 2. This is my equation 1. Equation 1. So you can now substitute 2 into a 1. And I substitute, we have K1, this E here, E0 minus ES into bracket S, concentration of X minus K minus 1 EX minus K2 EX equals to 0. This. Then when I open the bracket, this is a bracket. So I multiply this by this by this, multiply this by this by this, multiply this by this. We have K E0, then times X again, and this one times this is K1. So this times this minus K1 EX X, and multiply this minus K minus 1 EX minus K2 EX equals to 0. So everything here has ES. So now I want to eliminate ES so I can transfer this to the other side. So I have K1 E0 S equals to K1 ES S minus plus K minus 1 ES plus K2 ES. So when I have this, I can bring E2 ES outside bracket and bring everything together. I have K1 E0 S equals to K1 S plus K minus 1 plus K2, everything to bracket ES. So that when I multiply this by this by this by this, I get this back. So for me to get my ES now, I can divide both sides by this. So EX equals to K1 E0 S. All over when I divide this by this, I have K1 of X plus K minus 1 plus K2. But from here, the velocity of the reaction in terms of product here so as to eliminate Ex and get our Michaelis-Menten equation. We'll be given as the P the T equals to K2 ES. To not have any minus because we are writing time of product. It's the same thing as velocity as the time velocity, that is the rate at which is formed, Ex. So I can substitute my Ex from here into this equation. Therefore, when I substitute this, okay, this is K2, sorry, V here equals to K2EX, consideration of EX. So I can substitute this here. EX, since EX equals to this, so I can say V equals to K2 K1 this E naught X. This is multiplication of K1X plus K minus 1 plus K2. So I can divide this. Let's say this is our equation 3. I can divide this, both numerator and denominator, by K1. So we have something like this: V equals to K2 K1 E naught X all over K1 all divided by K1 X all over K1 plus K minus 1 plus K2 all over K1, such that when I look for the SCM, I still get this back. So this cancel this cancel this, and therefore V equals to K2 E naught X all over X plus K minus 1 plus K2 all over K1, where this K minus 1 plus K2 all over K1, this is backward reaction, and the rate of at this formula of forward reaction will give us K max. These are Michaelis-Menten constant. Therefore, this can be written as V equals to K2 E naught X all over X plus K substitute max. But from equation 2, when all the enzyme has been replaced, has finished, as in where it has been is concentrated, and we have no ES again, equation 2 will become E equals to E naught at maximum velocity, the rate at which you don't have any EX as in the intermediate anymore, that is, everything has been converted to the product. So at this point, this from here equals to V maximum, is equals to E naught. So at this point we have our V to be equals to V maximum to be equals to K2 E naught. You can substitute this here. Let's say this is our another equation. You can put this into this. So we have V equals to V max X multiplied by X. This is equals to, let me write it everywhere. V equals to V max X Square root of x all over x plus k max, and this is called the Michaelis-Menten equation. Our k max is our Michaelis-Menten constant, so this is our Michaelis-Menten equation. This is V max. So we're going to substitute equation 4 Michaelis-Menten equation.